Okay, live stream is up and looks healthy. Lots of bandwidth today. That's good. So let's jump into the textbook. So we're looking at page 354 in the FTD textbook. Now there are a few different ways of easily drawing 3D by hand. And there's a variety of different what we call projections that are used in 3D hand drafting. And these aren't just used in hand drafting, they're also used by CAD programs as well in terms of a form of projection. So, of course, what you notice with all of these is that the verticals are always drawn vertically on the screen. In real life, of course, even as you were to move these cubes around, even if you could kind of keep it on a turntable and walk around and look at it on a turntable, we see things in perspective, and therefore you've got a little bit of foreshortening that would occur, and as a result, these two lines, when looked at it in a regular view, just with our eyes, would not be perfectly parallel. So there is some sort of, I don't know if approximations is the right word, but it's not exactly what we would see. If you folks have ever looked at bird's eye satellite photos of cities, you can really see the sort of how the presentation gets really isometric, because from the distance that the satellite is away from the subject, the lines of the buildings all do end up almost perfectly vertical, and it's a really bizarre presentation. But with isometrics, that's basically the view that you get. So it's a 3D view without any parallax or any perspective in it. So, and it's actually easily drawn. So what we do when we're doing isometric drafting, so you can see there's the three different presentations that they show here, and the one that's used by far and away is isometric. And it's done by use of the 30-degree square. So you place your 30-degree square down, and you can see here that you're going to get each side to draw those lines. And what we're looking at here is called the isometric cube. So there's a left face, a right face, and a top face. So when you are working with these faces, you can measure along them. So here, if I want to draw something that's 6 millimeters long on the left isometric face, I can just put my scale directly on my paper and draw that up. So you have sort of your X, Y, and Z. And when drafting, you can just mark, like I said, anywhere along those axes. So you've got these three axes that you will always use. So you'll put your scale on the vertical axis, or the left axis, or the right axis. And like I said, just measure along those axes to draw something up. Now, sometimes we run into objects, of course, or very frequently, in fact, where the sides of the object have cutouts in them. Now, this face here is on the left isometric plane, and trying to figure out how to draw this chamfer, and it probably is a 45-degree angle, but we would not be able to use a protractor to sort out these two sides. So for this kind of work, we sort of avoid going to the protractor and instead focus on the virtual lines that would construct the object if it did not have the chamfer in it, like that. And then what we would do is we would measure the distance down on each side based on the depth of the chamfer. So we might have to measure, our side view and just see how much of a drop that we're going to have in those cases. And now, because we're looking at something that's got a depth, what we would start doing is we would, on the top plane, lay out the flat plate piece here and hole, and then draw this next face here. And then once that's done, we would switch to our right isometric plane and just draw the lines backwards based on the depth of the object. And then in the vertical plane, draw the depth downwards for the thickness of the object at the bottom. So there's any number of ways that you could present this object, but if you were to look at the shape of it, you're going to draw it so that as much of its details and much of its shape are shown as possible. So we don't want to spend a whole lot of time drawing more isometric views than we want to, so we would choose a view that would gain us the best view of the object. So you have a bottom view and a top view, and of course this what they call like a top left view or a top right view would be the one that's always chosen. In some cases, if they need to show some details of below the part, they would do so. So that's kind of the lay of the land for how this works. Now we're going to talk about isometric circles next. Now you can see we've got the three isometric planes. So here viewed from below, and then here viewed from above. So typically when we're drawing something, we're looking down on top of it. So there's your top isoplane and your left and your right. So the next thing that we're going to be looking at is how we construct these isometric circles. Now I have a handout for this, and it's got a really good layout of how you set this up. So what I might do is get you folks to go and download that and refer to it. So if you go into the ADT1 channel, I've put in the PDF for this. So this is the one that's on isometric circles, and so we're just going to step through that here. I'm just going to pull it up here on my screen. So in that PDF, you can see the three circles, and it's got some lines or some leaders on it, like with the little black arrows, and those show where your compass points need to be to draw the circle in question. So when you're looking at these isometric circles, when someone draws them, first of all, you construct the virtual box to create your isometric circle. So let's take the circle for the isometric top plane. So I've got it up on my screen here, and if you look at the notes here, so first of all, you construct the virtual box that defines the top isoplane, and it's the ultimate outside of the circle. So if you're drawing an isometric circle that has a radius of 10, then each side of the square would be 10 units. Then you draw you bisect those sides into two halves and draw those out. And these are all with construction lines, so it's got to stay pretty light in terms of how you draw it. Now, after you've drawn the square bisectors, you draw a construction line from the vertex of the obtuse angle that gets created, so one here, and you can see how we draw construction lines from that obtuse angle down to the other side here. And then we draw a bisector horizontally across. And so where these two connect, you put your cursor there. Not your cursor, your compass. You put your compass there, and where the compass intersects the side of the isometric cube, away you go, and you just draw that whole thing up. So there's that one drawn. Now, to draw this curve here, so what we're aiming to do is we're aiming to get curves drawn for all four of these boxes. So this curve is from here, and of course the next curve is starting from here, and we draw this curve. And then the top and bottom boxes here, put our cursor at the corners and draw those curves. And every time I do this, I'm astonished at how natural these things look. Now, if you're a math dork, you know that this kind of a projection actually gives you an ellipse. This is not really doing a true ellipse, because an ellipse is not just four circles of two different radii. It's a much tougher animal than that. But for the purposes of isometric drafting, this is actually, it's a pretty cool way to approximate it, and it looks legit. Like when you're looking at this thing on the screen, it doesn't, or on your paper, it doesn't look unnatural. So drawing these things on the other planes, you just simply take this thing and you set it up for the other isoplane. So this one that we are looking here is the other isoplane. Now this is a slightly different construction method than is shown in the handout. With the handout, there's actually fewer construction lines that you have to draw, because in the handout, once you've found the bisectors on all sides, you don't have to draw the lines through them. In the handout, it just suggests that you do this. So there's going to be these four construction lines that you'll draw, and I'll note them here. So while you do have to measure the box to break it into four pieces, there is no need to draw the lines through the box, nor is there this need to draw this line horizontally. So let me grab my trace paper here. There's, as you can see, there's varying ways to construct these things, but we've just put one together here that makes it so it's as few lines as possible. So you will draw, again, red is going to be as if it was construction lines, so very light as possible. And then for your construction lines, once you've figured out where your bisectors are, just put ticks there. That'll be sufficient. Draw from the obtuse corners lines to the opposite bisectors. There you go. So those are, wow, did not hit that at all. Okay, so that done, then what we can do is draw our two arcs, two different radii. So starting from here and here, so that's one of them, and I'll switch to red for the others so it's very clear which is which. You start from here and across to the other side, and that will connect these two together, and then one here. And then this one here. Okay, so that's the basics of isometric parallel line and curve drafting. So what we'll do here, where are we at here? We're at 9:18, 9:20. I'm going to end the stream just for a moment, and then we'll come back and we'll do the quick exercise that was mentioned in the notes. It's the first exercise. It's called the Isometric 3D assignment, and it's got a 3 views, the top, front, and side view, and it's got a little curved piece on the front of it in the front view that sticks up with a rectangular cutout. If you want to grab that and print it out, we'll come back and look at that in about 1 minute. Now, maybe what I'll do, just to give you folks some time to print that out, we'll take 5 minutes here. It's 9:20. We'll come back at 9:25 and carry on.